that would be 5 factorial, divided by 5 minus 1 would be 4 factorial, and 1 factorial. And then we're going to multiply that by 8 comma 2, which would be 8 factorial, divided by 8 minus 2, which is 6 factorial, and the last number, which is 2 factorial. Solving this out, 5 factorial would be 5, 4, 3, 2, and 1. And 4 factorial would be 4, 3, 2, 1. 1 factorial would just be 1. 8 factorial would be 8 down to 1. 6 factorial would be 6 down to 1. And 2 factorial would be 2 and 1. Crossing off what's in common, 4, 3, 2, 1 on the first fraction cancels. 6 through 1 also cancels. The 1 on the first fraction we can ignore, and the 2, we can divide the 8 by 2 to get 4. So we're left with 5 in the first fraction, and we have 4 times 7, which is 28 in the second fraction. Multiplying that out, and that gives us 140 for the numerator. Again, combination 25 comma 3 we solved in the previous problem was 2300. Reducing this, you can divide each of these by 20, and your final answer would be 7 over 115. And again, if Bob wants to pick out 1 basketball and 2 football cards, he has a 7 out of 115 chance to do so. First problem we'll solve is a die is rolled twice. Find the probability of rolling a 5, then a 1. These events are independent. When we roll the die the first time, it does not affect the die when we roll it a second time. First number we're looking for is a 5. There is 1 5 on a 6-sided die. Over the possible outcomes, there are 6 different numbers that we could roll. So the probability of the first event, 1 out of 6 for rolling a 5. Multiplied by the probability of the second event. Probability of rolling a 1, there's a single 1 on a 6-sided die, again out of 6 total possible outcomes. Multiplying across, the probability of a 5, then a 1, would be 1 out of 36. Second problem will be the probability of rolling 2 different numbers, again when we roll a die twice. The first time that we roll a die, it does not matter which number we roll, so we could roll any of the 6 numbers out of the 6 possible outcomes. The second event, we have to roll a different number from one of the first 6 that we rolled. It does not matter which number we roll, there will be 5 different numbers besides that number. And again, there are 6 total numbers on a 6-sided die. Multiplying across, 6 times 5 would be 30 over 36. Reducing would be 5 over 6. So we'd have a 5 out of 6 chance of rolling 2 different numbers. For this problem, we will be drawing letters from a word game, and we want to find the probability of drawing a E followed by a N if replacement occurs. Replacement means after we draw the first tile, we'll put that back in the box, and then we'll draw the second tile. Find the probability of E. Looking at the letters given, we have E, T, F, U, N, X, and P. There is a single E over 7 total tiles, so we have a probability of 1 over 7 for drawing a E. Multiplied by the second probability of drawing a N. There's a single N. After we draw the E, it is replaced back in the box, so there's still 7 possible letters, so there's a 1 out of 7 chance of getting a N. Multiplying across, our final probability would be 1 over 49, which is the probability of drawing a E followed by an N. For the second problem, we want to find the probability of drawing a X, then a P, if no replacement occurs. No replacement means after we draw the X, we'll take the X tile out. It's no longer in the possible outcomes, and then we want to draw a P after that. Again, the probability of drawing the X, there's a single X. There are 7 total letters at the beginning of this problem, so a 1 out of 7 chance of drawing an X. Once we take that X out, again, the X is no longer among the letters, so it reduces our possible outcomes. Chance of drawing a P, there's a single P. And instead of 7 letters, since we took the X out and did not replace that, there are now 6 letters in the box. Multiplying across, our final answer for this problem would be 1 over 42, which is the chance of drawing a X, then a P, if no replacement occurs. Mutually exclusive or inclusive. There are 2 types of events when dealing with probability. Mutually exclusive events are events that have nothing in common. There is no overlap or no event that happens at the same time. Inclusive events, something in common. When you have 2 events that are inclusive, it means you can have one outcome be part of 2 different groups, so they have an event or something in common. First problem we'll look at is rolling a 3 or an odd number on a die. The 2 events, first event is rolling a 3, the second event is rolling a odd number. To determine if they're mutually exclusive or inclusive, you want to see if they have anything in common or any overlap. For example, if you roll a 3 is an odd number, so rolling a 3 would be part of both groups, which means they have something in common, so these events would be inclusive. Inclusive again means you have something in common, there's a overlap, the number 3 would be in both groups. Second question and last question for the section. Choosing one boy and one girl in the class. The 2 events are choosing one boy and the second event's choosing one girl. Since boys and girls are separate categories, there is no overlap or nothing in common. Nothing in common, these events would be mutually exclusive. Mutually exclusive again, the events are completely separate, so they have nothing in common and there is no overlap. probability of mutually exclusive events. If you have two events which are mutually exclusive and do not have anything in common, the probability of the two events, probability of event A happening or event B, would be the addition property. You can take the two probabilities and add those together. So the probability of A or B would be the probability of A plus the probability of B. We'll use this in the next example where Jesse will be choosing 3 friends and 5 are boys and 3 are girls. First problem we'll solve using the word problem is to find the probability that we will have 2 boys selected or 2 girls selected. Again, 2 different events, 2 boys or 2 girls, mutually exclusive, since if we have 2 boys, we cannot have 2 girls, and they would not have anything in common. The addition property, we can find the probability of 2 boys and add to that the probability of 2 girls. The first probability of 2 boys would be a combination. Anytime you're picking multiple events and the order does not matter, does not matter if the boy is picked first or last, as long as we have 2 boys, we'll do a combination. The first number in the combination again is the total amount. In the word problem we have 5 boys to choose from, and again we want to find 2 of those to be boys, so the combination will be 5, 2. Multiplying that by the second choice, if we're picking 2 boys, in that same scenario we'll end up picking 1 girl. So we'll have a second combination for 2 boys, and we'll have a combination for having 1 girl from the 3 that we pick. The amount of girls would be 3, and if we pick 2 boys, we'll have a single girl we'll be picking. So the number of ways to pick 2 boys would be combination 5, 2 for the 2 boys, and combination 3, 1 for the 1 girl in the 2 boys scenario. And again, probabilities will make fractions. The combination for the denominators, the total number of ways you can pick 3 people. There's 8 people to choose from, 5 boys and 3 girls, and we'll be choosing 3 of those, so we have 2 boys and 1 girl. The second fraction will add to that. First fraction was probability of 2 boys. The second fraction will be the probability of 2 girls. Again, a combination, since the order does not matter on the number of girls that we select. There's 3 girls total, and again we want to pick 2 of those. So combination 3, 2 is the number of ways to pick 2 girls. Since we're picking 2 girls, the one left over has to be a boy. So multiplying by the number of ways to pick a single boy, there's 5 boys altogether, and we're picking a single one. So the number of ways to pick 2 girls would be combination 3, 2 for the 2 girls times the combination for the 1 extra boy, 5, 1. The denominator will be the same as the first fraction, 8 people altogether, and we're picking 3, so the total number of ways to pick 3 people would be combination 8, 3. Solving from here, we can change these 2 factorials. Combination 5, 2 would be 5 factorial divided by, subtracting the 2 numbers, 5 minus 2 would be 3 factorial, and combination have the extra factorial on the bottom, which is 2 factorial. Multiplying by the second combination, 3, 1. 3 factorial would be the numerator. Subtracting 3 minus 1 would be 2 factorial, and the extra factorial for combination would be 1 factorial. For the denominator, combination 8, 3. 8 factorial will be the numerator, divided by 8 minus 3 will be 5 factorial, and the extra factorial, 3 factorial in the denominator. The second fraction will add to that for the 2 girls. Combination 3, 2 would be 3 factorial, divided by, subtracting them would be 1 factorial, and the extra 2 comes down for 2 factorial. Times combination 5, 1 would be 5 factorial, subtracting would be 4 factorial, and the extra 1 factorial. The denominator, combination 8, 3, again is the same denominator, 8 factorial divided by 5 factorial, and 3 factorial. Solving from here, we can write out the factorials and cancel the numbers in common. 5 factorial would be 5, 4, 3, 2, 1. Divided by 3 factorial, 3, 2, 1, and 2 factorial, 2, 1. Times 3 factorial would be 3, 2, 1. 2 factorial would be 2 and 1, and 1 factorial would be 1. Divided by, again, our denominator, 8 factorial, which again would be 8, 7, 6, 5, 4, 3, 2, 1. And the denominator for that one, 5 factorial, 5, 4, 3, 2, 1, and 3 factorial, 3, 2, 1. Adding to that the second fraction, 3 factorial would be 3, 2, 1. 1 factorial would be 1, and 2 factorial would be 2 and 1. Times 5 factorial, 5, 4, 3, 2, 1, over 4 factorial, 4, 3, 2, 1, and a single 1 factorial, which would be 1. And the denominator, again, both the same, 8 factorial, 5 factorial, and 3 factorial. From here, we can cancel the numbers in common. The first fraction, 3, 2, 1, will cancel out. And if you divide by 2, we'll be left with a 5 and 2 in the numerator. Times the second fraction, 2 and 1 will cancel, and the single 1 we can ignore, so we'll be left with a 3 for the second fraction. For the denominator, 5, 4, 3, 2, 1 will cancel. 3 times 2 would be 6, so we'd cancel the 6 and the 3 times 2. And the 1 again we can ignore, so we'll be left with 8 and 7. The second fraction, 2 and 1 we can cancel, and the single 1 we can ignore, so we're left with a 3. Times 4, 3, 2, 1 cancels. The 1 we can ignore, so we're left with a single 5. And the denominator, just like the first fraction, 5 through 1 cancels, and the 6 and the 3 and the 2 cancels, and the 1 we can ignore. Rewriting the numbers, we'll have 5 and 2 left in the first fraction. Multiplying 5 times 2 would be 10. Times the second fraction, we have a 3 left. For the denominator, we have 8 times 7, which would be 56. Adding to that the second fraction, we have a 3 in the first fraction, a 5 in the second fraction, multiplying those. And again, the denominator, we have 8 times 7, which would be 56. And again, the denominator, we have 8 times 7, which would be 56. Simplifying, 10 times 3 will have 30 over 56, plus 3 times 5 would be 15 over 56. Adding those together, we'll have 45 over 56. This fraction cannot be reduced, so our final answer, 45 over 56, which again is the probability of picking 2 boys or 2 girls. Probability of 2 boys is 30 over 56. Probability of 2 girls is 15 over 56. So the total probability, 45 out of 56. Last question for the section. Having the same word problem, we'll find the probability we'll have at least 2 girls. At least 2 girls means we could have 2 girls or more. Since we're picking 3 people, we can either have 2 girls or 3 girls. So the first fraction we'll set up for the probability is the probability of 2 girls. Again, a combination. The number of girls total would be 3. And if we're picking 2 girls, that would be 3 comma 2. Multiplying a second combination. If we pick 2 girls, that means the other one has to be a boy. Combination, 5 total boys, and we'll be picking 1. So the number of ways to pick 2 girls would be combination 3 comma 2 times combination 5 comma 1. Setting the fraction up again, the combination. Same denominator as we had before. There's 8 total people, and we're picking 3 people from those 8. So the total number of possibilities, combination 8, 3. Adding to this, the second outcome, at least 2 girls means 2 girls or 3 girls. So the second fraction, a combination, will be picking 3 girls. There's 3 girls total, and we want to choose all 3 of those. So combination would be 3, 3. Since we're picking 3 girls, there's no boys left to pick, so there's no other combination to multiply by. 3 girls would just be 3, 3. And the denominator, combination 8, 3. 8 total people and 3 girls we're picking. Looking back at the previous question, this first fraction, the probability or chance of 2 girls, 3, 2, 5, 1, and 8, 3. We actually solved that. That was the second fraction of the previous question, and that came out to be 15 over 56. So the first entire fraction, same work we had before, 15 over 56. We'll add to that the new fraction, combination 3, 3 over combination 8, 3. Combination 3, 3 would be 3 factorial divided by subtracting the numbers 0 factorial and the extra 3 on the bottom, 3 factorial. And a fraction line, combination 8, 3. Again, you can write out the factorials, which would be 8 factorial over subtracting 5 factorial and 3 factorial. Solving from here, the 3 factorial would be 3 times 2 times 1. Definition of 0 factorial, since we cannot multiply by numbers less than 0 and we're already below 1, the definition of 0 factorial is equal to 1. So anytime you have 0 factorial by definition equals 1. And 3 factorial will have 3, 2, and 1. Divided by 8 factorial, 5 factorial, and 3 factorial. Again, this one we did in the previous problem. It's the same answer, same denominator, which would be 56. Simplifying the second fraction, 3, 2, 1 will cancel. The 1 we can cancel. In this fraction, all the numbers divide out. Keep in mind when you're dividing, 3 divided by 3, 2 divided by 2, or 1 divided by 1. The answer would be 1 when we're dividing, or if everything cancels out, we'll be left with 1. Our first fraction again from the previous problem, 15 over 56. Adding to that the second fraction, we have a single 1 left over 56. So the probability of 3 girls is 1 over 56. Probability of 2 girls is 15 over 56. Adding those together, we'll have 16 over 56. Dividing those out, or reducing, you can divide each number by 8. So our final answer would be 2 over 7. So the probability of picking at least 2 girls, which is either 2 girls or 3 girls, the probability would be 2 over 7. Title of the first section is Finding the Next Term in a Arithmetic Sequence. Directions for the first part are we're going to find the next 4 terms. First sequence we'll look at is 2, 4, 6, and dot 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 afterwards means the sequence continues forever and ever. A arithmetic sequence means the sequence goes up or down by the same number each time. So for example, 2, 4, and 6, each term increases by 2, so the next number also increases by 2, which would be 8. And we'll find the next 4 terms. Increasing by 2 would be 10, third term would be 12, and the last term, our fourth terms, would be 8, 10, 12, and 14. Next sequence and last question for the section. 55, 49, 43. Again, we'll find the next 4 terms in the sequence. 55 to 49 decreases, and it's decreasing by 6. 49 to 43 also decreases by 6, so each term thereafter will decrease by 6. 43 subtracting 6 would be 37. Subtracting 6 again would be 31. Subtracting 6 again is 25. And the last term, the fourth term we'll find, would be 19. So the next 4 terms in this sequence would be 37, 31, 25, and 19. Next section of notes is titled Finding Terms. Of a arithmetic sequence. Two variables or definitions for the section. A sub 1 or A1 equals the first term of the sequence, and D will be the difference of the sequence. Again, arithmetic sequences go either up or down by the same number, and that number would be the difference. For these problems, we will find the first 5 terms. First question, A sub 1 or A1 equals 5, and D is equal to 3. Find the first 5 terms. A sub 1, the first term, is the first number, which would be 5. Difference of 3, which is positive 3, means each number goes up by 3. So if the first number is 5, second number increasing by 3 would be 8, and we'll continue for 5 terms. Increasing by 3 would be 11, then 14, and then 17. So our first 5 terms would be 5, 8, 11, 14, and 17. Next question and last question for the section. A sub 1 is 14, and D equals a negative 2. The negative 2 represents the sequences decreasing or getting smaller. First term again would be 14, and each term after that increases or decreases by a negative 2. 14 minus 2 would be 12, minus 2 again would be 10, and again we'll continue for 5 terms, which would be 8 and then 6.